Hi, so I'm Aaron, and today in the chemistry world, we're going to be talking about the difference between ionic and covalent bonds. So essentially, what an ionic bond is it's a metal bonded with a nonmetal, and so that's from the alkali metals or the alkali earth metals or the transition metals bonded with something on the right side of the periodic table. And essentially, the reason that happens is because let's say, for example, you're trying to bond magnesium with oxygen. Oxygen has a negative 2 charge because it's looking to lose gain 2 electrons because it has a valence electron number of 6. And magnesium, on the other hand, has a positive 2 charge because it only has 2 valence electrons, which means instead of trying to gain electrons, it's going to try to lose those electrons in bonding with other atoms. So when you bond magnesium and oxygen, you get 1 magnesium to 1 oxygen because it's a positive 2 charge to a negative 2 charge. And ionic bonds, when they bond together, it creates what's called a lattice, which is a kind of, it's what it is, it's what it sounds like. It's a lattice structure of atoms that are connected by positive and negative charges all across the lattice. And it's a strong bond. However, it's quite brittle. So while the polarization of the 2 atoms create strong bonds, you can still knock off chunks of it, and then those chunks can be rearranged, and it's quite brittle. Now, covalent bonds, however, are the opposite of that. Instead of creating a lattice, what they create is a molecule such as water. So covalent bonds are when you have 1 or 2 or more atoms that are nonmetals that are bonded together. And the way those bond together, instead of gaining and losing electrons, they share electrons with each other, which is pretty interesting, I think. It's pretty cool. So those create molecules, like water, for example. We're going to use water for a second. So water is incredibly polar. Now, you can have different polarizations. Now, the most polar atoms that you can have are ionic because those are from positive and negative charges, and those are usually pretty polar. But you can still have fairly polar molecules that you get from covalent bonds, such as water, because water in its Lewis dot diagram has 2 unpaired two sets of unpaired electrons. So what those do is they create electron domains around the actual central atom, and those create polarity. And water is actually quite polar in comparison to other molecules, which could be still slightly polar. And a way if you see if a molecule is polar or nonpolar is if you look at it and see if it's relatively spread out. Like a molecule can have polar bonds, but it can still be nonpolar. Like you can have H bonding all around an atom, but if there's just a bunch of hydrogens, say, around boron, it would be nonpolar. So like 3 hydrogens. Okay, so something interesting to note about boron. Boron is a moron. So boron is the only atom on the entire periodic table that will have less than 8. Some of these atoms they need at least 8, but more than 8. But boron is a moron, and boron only needs 6 valence electrons to be stable enough to create molecules. And so the only atoms that only need 8 valence electrons are in the first period of the p blocks, except for boron. So that's carbon, nitrogen, oxygen, and fluorine. And H bonding occurs with nitrogen, oxygen, and fluorine. And H bonding is some of the strongest bonds that you can have. So when you have hydrogen bonds, it's ridiculously strong. And so the difference in polarities has to do with the intramolecular forces that are inside of molecules, and those differ from intermolecular forces that occur when two molecules bond together, like if you have two water molecules bonding together. So the intramolecular forces, from least to greatest effect on polarity, it goes London dispersion forces, which all atoms have, no matter whether polar or not. However, the larger an atom, the larger the London dispersion force is, and just that could cause the atom to be polar. However, that's not as large of an effect on the polarity of the atom as something like dipole dipole is, and that's when you have like an uneven spread out atom, and that's when the atom is clearly nonpolar. Like, let's say you have carbon, 3 fluorines, and an oxygen, for example. Because of the fact that there's one atom that's different, then it's nonpolar. But if it was carbon tetrafluoride, for example, that would be polar, because the atom would be evenly spread out. And lastly, H bonding, which is hydrogen bonding, which occurs in nitrogen, oxygen, and fluorine, and that's the strongest bond that you can have with any atom, and that creates the most polar atoms. And however, ionic bonds will still always have more polarity because of their charges. And ionic bonds also have more polarity if their charges are greater. Like, let's say, for example, you want to bond sodium and oxygen. Sodium would have a positive 1 charge, oxygen would have a negative 2 charge. However, you need 2 sodiums for that 1 oxygen, so it would be Na2O1, which would end up having a stronger polarity than magnesium oxide, which would be a 1-to-1 ratio. And yeah, so that's the difference between ionic and covalent bonds and how those relate to molecular and lattice polarity.